Welcome to the APL quest. See APL Wiki for details. Today's problem is the 7th from the 2015 round of the APL problem solving competition. It's very simple. We just are to extend membership a bit so that it is case insensitive. Now let's start with two arrays. Let's just take the first 6 letters of the alphabet and also some random 4 letters here. And if we try to do a membership here, it doesn't work. It says that none of these letters are members, even though clearly C and D are, and that's because they have different letter case. So what we need to do is we have our 2 arguments, and we need to case fold them, which is a normalization procedure done so that we can compare case insensitively. And so we apply quad C, which is case fold, on the left argument and also on the right argument. And now we can see that C and D are indeed members. But we can make this look a whole lot nicer. Let's start by converting this to a tacit function. So instead of using omega, we're using right tag. Instead of using alpha, we're using left tag, and that still works. But this is a 2 train. Those are tops, and we can then use the top operator instead. Now we can observe that we are pre-processing the left argument and the right argument in exactly the same way. Instead of using the function quad C twice, we can do it once just using the over operator. So that's on the right and on the left, but we don't need to state that. And we don't even need any parentheses because this isn't a train anymore. It's a simple derived function. However, the problem statement says that it should also work for high rank arrays. And that doesn't work here. Let's make this into a high rank array here. 3 rows, 2 columns. And we also over here, 2 rows, 2 columns. And now we should say that these rows here are members. So the CD row is indeed a member of the matrix on the right. And we should get 0, 1, 0. But if we try it, then we get a strange result. And that is because membership works on element by element basis. So it says, is A a member of this matrix over here? Is B a member of the matrix? Is C a member? And is D a member? And that's not what we wanted. Even though we might think we could do an AND reduction across, but that doesn't work, because that would give us the elements even though they're in the wrong order. It would say they're members, and we need the entire row to match. What we want to do is we want to do a membership between the major cells. And we can do that by starting off in isolating the major cells with the over again. So we can say membership of case insensitivity on the enclosed major cells. And that works. And there are different ways that we could mix and match this. However, there are actually a better way to do it. And that is by not using membership at all. Instead, let's look at the result of dyadic iota, which is index off with opposite argument order. What this is saying is, where do we find the major cells from the right, that is now left, in the other argument? And so what it's saying here is that AB is found in position 3 on the right. That is the next available index after the last one, meaning it isn't found. And CD is found in the first one. And EF is found, well, it's not found. So 3 again. And that means, since we're not interested in the actual position, only whether or not it's there, then if it's within the range, that means it's a member. If it's outside of the range, then it's not a member. and we're interested in whether it is in the range. What does it mean in the range? That means no more than the length of the element that we're looking for. So this is the length of the right argument. That's 2. And so we can put this in, and we can say if the index of each one, done case insensitively, is less than or equal to the maximum, then we know it's a member. And that gives us our solution. Can give it a name. Then we don't need parentheses. And then we can use the name in here. That's our solution. Thank you for watching.